Hello friends, I welcome all of you. In this video, we'll talk about TCP/IP model. It's basically a four-layer model which is being used in internet today. So all of the devices which you use or which you have seen in recent days, all are compatible with the TCP/IP protocol suite. So now you will ask me, then why did you talk about OSI model? See, OSI was built by, first of all, ISO, that is International Standard for Organizations, and TCP/IP, it was introduced by US Defense Department. OSI is a conceptual model, it's a reference model which is very helpful to make you understand the flow of traffic from top to bottom and bottom to top at the receiving end. And it talks about the packet flow. It helps in troubleshooting. However, it is not a practical model right now. The only most accepted, in fact, the only model is TCP/IP, which is very practical and it is being used right now. So there were some challenges and difficulties with the OSI model. Like in past, there were many vendors who were using their own routed protocol for addressing. Like nowadays we use only IPv4 or IPv6, but now it is only IP. But at that time, like in 1960s, we used to have protocols like IPX, AppleTalk, NetBIOS. And if one vendor was using NetBIOS and I was using IPX, then compatibility issue was there. Or if third one is using NetBIOS and fourth is IP, then the communication was not happening that effectively because of the compatibility. So in the nutshell, there was no common ground. Okay. So what is a protocol? So it is basically a set of rules which is accepted by all the parties. So common ground. So here we have four layers. If you look at the screen, the first three layers of OSI model, that is layer number 7, 6 and 5, these have been merged and named as application layer only. Transport layer is intact. The network layer, it has been named as internet layer, and the last two layers like data link and physical layer, these have been merged and renamed as network interface layer. So only four layers. Okay, so now you'll ask me, only TCP is there in this protocol suite, because suite means a collection of protocols. See, we also have UDP, but most of the applications in the world today, these are heavily dependent on TCP, transmission control protocol. However, some applications also use UDP, like voice-based application, video-based, which are very time sensitive, right? And DNS as well. But most of the applications are using TCP as a transport layer protocol, because TCP ensures end-to-end delivery of the data. Okay, and we can also use UDP. UDP is a part of the suite, but due to its popularity, it is named as TCP/IP. Okay, so IP works in the network layer of OSI model, or you may call it internet layer of the TCP/IP model. So IP is a routed protocol. Okay, your address. So what is the function of layer 3, that is network layer? It does the routing. It directs you to the best or shortest next hop, right? So it gives directions. And TCP, that is transport layer, it ensures end-to-end delivery of your data. Okay, so let me revise these four layers right now. So all the process level communication between two hosts it'll be taken care by application layer. Okay, so if you have client and then server, client of course will follow these 4 layers, and the same server, that is destination workstation, will also have these 4 layers. So all the process level communication will happen or will be done by the application layer. And then this transport layer, it will, what it does, I told you, it also divides the data into segments and adds a header. All right, so segment level communication will happen and will be taken care by transport layer. Then this packet level communication, here segments will be further divided into packets. Okay, and friends, segment, when I say, it means we are using TCP, but if you are using UDP, it will be user datagram, right? And don't forget that, because TCP is the most popular protocol. Almost all of the applications like Telnet, SSH, SMTP, HTTP, HTTPS, MRDP. So there are many. Okay. So at the internet layer, the segments will be divided into packets and extra header will be added. And in the network interface layer, functionality wise, it will do the same thing, but it ensures that IP is the only protocol, router protocol is used. So if you check your Android phone, you'll find that your phone has an IP address only. It can be the IPv4 or IPv6. You will not find Apple Talk. So Apple Talk was it was an address being used by Apple machines. Then there was Net BIOS, which was introduced by, I think, Novel was a company, right? And then there was IPX. I don't remember who introduced, but it is of no significance right now. Okay, and there was a perhaps I didn't tell you, there was a protocol named SNAP, SNAP, which you will know once you do routing protocols, especially the IS to IS, IS-IS, which means intermediate system to intermediate system. Once you understand that routing protocol, you'll find SNAP addressing being used. Okay, so SNAP was also introduced to resolve the issues of these incompatibility of the addressing. It used to add additional header, but it still it didn't help much. So TCP IP was widely accepted. All right, so as a recap, just understand this, whatever I've written. It is a foundational suite of protocols that drives communication across the internet and networks. It enables end-to-end transmission. So this end-to-end transmission is basically the responsibility of the TCP. And TCP has many benefits compared to UDP. TCP is connection oriented, UDP is connectionless. We'll talk about it once we reach at that point, but let me also give you some high level idea. UDP is connectionless. So when we talk over the phone, then you will notice that UDP protocol is used, because when we say something, it should be immediately delivered within, you can say, less than 300 milliseconds, right? So you must notice that once our call gets some issue, it is immediately dropped, because UDP doesn't do error recovery. It doesn't maintain the flow control. It doesn't have any concept of flow control, windowing, right? So, but it is fast. It doesn't do error recovery as well. Okay, but it's a connectionless. It doesn't maintain connection. Once the connection is dropped, it is dropped. So this is the benefit, or you can say disadvantages of UDP. But all the voice, video traffic, these use UDP protocol, and some of the business critical applications which need immediate response. Immediate means less than, let's say, 10 milliseconds. Then those kind of applications use UDP. All right. TFTP uses, I think, UDP 69, if I remember correctly. Yes. And TCP has flow control. It makes sure that your data segments are delivered in a right order. These don't get mixed up, and it ensures flow control. Okay. It has concept of windowing this to maintain the sizes, segment size, and it's a connection oriented. It maintains connection. It also does error recovery. So these are the sorry these are the main differences between TCP and UDP. Okay. Again, it's a collection of protocols. TCP being the most popular, that is why it is called TCP/IP. But IP is the only layer 3 protocol, layer 3 routed protocol we use. Understand that. So this is the practical model. Again, you may read all of these things. Link layer. Link layer actually the network interface layer. You may call it link layer. That is up to you. Internet layer is your network layer. Transport layer is same. You understood. Application layer is the combination of 3 layers now. It also contains presentation and session. Okay. So it's a backbone of all modern network communications, including the internet. So it is essential for networking, troubleshooting, and securing networks. Okay. So this is the only practical model. So I hope I've been able to give you good guidance. So do give me appropriate rating and feedback. Thank you so much for your time. Have a nice day.